The Large Magellanic Cloud is among the closest galaxies to our own Milky Way, offering astronomers a detailed look at what makes a galaxy tick. One of its most striking features is the Tarantula Nebula, a star-forming region more active than any in ours or other neighboring galaxies. This is the source of most of the gamma rays we see from the LMC. Astronomers had thought the emission was a byproduct of star formation, which includes short-lived massive stars whose explosions produce shock waves that can accelerate particles. Interactions by these particles, called cosmic rays, can produce gamma rays, the highest energy form of light. But a discovery by NASA's Fermi Gamma Ray Space Telescope has turned this thinking on its head. Most of the emission arises from a single gamma ray pulsar, the first ever detected in another galaxy. Pulsar J0540-6919 turns out to be the most luminous gamma ray pulsar yet observed, beating the previous record holder, the famous Crab Nebula pulsar in the Milky Way, by 20 times. Discovered in X-rays using NASA's Einstein satellite in 1984, J0540 looked like a twin of the Crab until Fermi's Large Area Telescope unveiled its gamma ray power. While Fermi is the most sensitive gamma ray telescope ever launched, its vision is not as sharp as telescopes using other wavelengths. In 1998, NASA's RxTE satellite detected X-ray pulses from J0537-6910, a pulsar located just 16 arc minutes from J0540, or about half the apparent width of the Moon. In the early years of Fermi's mission, the two pulsars were seen only as a single steady gamma ray source. But the vision of Fermi's Large Area Telescope improves over time for two reasons. First, it collects more gamma rays, and each one adds to the story of cosmic sources. Second, Fermi scientists improve their knowledge of the instrument, allowing them to reanalyze existing data to tease out more detail. Thanks to new data and a reprocessing of old, Fermi scientists were finally able to detect gamma ray pulses from J0540, revealing its incredible luminosity. The object is responsible for perhaps 60% of the gamma rays from the Tarantula Nebula. The surprise that it's the pulsar, not the nebula, suggests astronomers need to revisit their understanding of how cosmic rays are produced and move through star-forming regions. And the best way to do that, of course, is to keep watching the sky.